My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 520. In this lecture, we will try to understand gradient descent algorithm, geometric intuition. So, when we learning about maxima and minima, we saw examples where solving df by dx equal to 0 or del f with respect to x equal 0. This is basically this del f with respect to x means this is related to it is vector sense, isn't it? In the context of vector, it is del f with respect to x equal 0. Solving these equations was not straightforward because solving this equation df by dx equal 0 could be tricky, where we said that solving these equations is not easy. When solving these equations are not easy, we have an alternative. The alternative is called gradient descent algorithm. A gradient descent algorithm is an iterative algorithm. A gradient descent algorithm is an iterative algorithm. It's an alternative algorithm which is very easy to implement in modern computer, and it works like this. First we make a guess of first we have to make a guess, isn't it? First we make a guess of what our x is. Pick a random number as your x naught. This is initial approximation. This is your first guess of your x star. That is, what is your x star? X star is your best x. Let me repeat. Pick a random number as your x naught. This x naught is your first guess of x star. It's a guess of whose guess is it? This is first guess of x star. What is x star? It's your best x, isn't it? Because the problem that we are trying to solve here is, let me say like this, let me assume, yes, like this. It gets the random value x naught, then using this x naught is first guess of x star, and what is this x1? Now it will move, I can say, using this the random number, it guesses the random value x0, then using gradient descent algorithm, now it will move to a new value x1, then it will go to x2. What is x naught? X naught is first guess, x1 is second guess, that is in iteration 1. In similar manner, x2 in iteration 2, xk in iteration k, which is xk, which is very close to x star. Objective in this iterative algorithm is, as your iteration number increases, you have to move closer and closer to x star. That is important, isn't it? That is your objective. Now let's see how it works. Let's understand gradient descent algorithm geometrically first. Let's take simplest example because this is intuitive. Let's assume I have a curve like this. Let me assume I have a curve like this. So for this curve, I want to find x star. What is my x star? X star is argument min of f of x. This is what I want to find. Imagine if I want to find maxima, always remember, if you want to minimize the function, minimization of f of x is equivalent to maximization of minus f of x. This is a very simple rule in optimization, or maximization of f of x is same as minimization of minus f of x. So if you learn for minima, you can do same thing for maxima by just changing the sign of the function. So if you know how to find the maxima or minima, it is easy to find other thing. It's easy to find other thing. Hence, let's study for minima. If you see visually, just see, if you see visually, this point is minima. Which point? This point is minima. Which one? This one. Let me say, this one is minima. This point is minima, because every other point value is greater than this value of f of x. F of x is greater at every other point except at origin. So now let's go to the core idea, core geometrical intuition. The core geometrical intuition of gradient descent. The geometry works like this. Let's take a point here. Let me assume I'm taking a point here. Just let me assume here I have a point. Let's take a point here. What happens here? Now its gradient, if you observe carefully, in this direction, if this is tangent, isn't it? In this direction, slope is, what is slope? Slope is, what is the slope here? Slope is positive, isn't it? Now its gradient is positive or slope is positive. I can say at this particular point, its gradient or slope is positive, isn't it? This is here theta lies between 0 and 90 degrees. This is positive value, isn't it? Here I have positive slope. Isn't it? What's the reason? Here theta lies in between 0 and 90. What is the slope at slope is positive as theta lies between 0 and 90. What is the slope here? What is the slope? For example, if I observe here, what is slope here? The slope at minima is 0, isn't it? The slope at minima is 0. The slope on one side of minima is positive, means on one side means, let me assume on right side, here slope is positive, here slope is 0. Here slope is 0, isn't it? The slope on one side of minima is positive. Let's look, and the slope at right side is positive, and at minima is 0. The slope at minima is 0. Here slope is 0. If you take tangent, this is tangent, isn't it? Therefore slope is 0. The slope on one side of minima is positive. Let's look at other side of minima. What is the slope? Let me assume, what is the slope here? Other side means what? Here what is the slope at this point, other side of the minima? The slope here is negative. Here slope here is negative. What is the angle with x-axis? Here theta lies between, here theta, I can say here theta, here what is the angle? Slope here is negative. What is the angle with x-axis? Is here when its theta lies between 90 degrees and 180 degrees. So what happens is around minima, on one side the slope is positive, means here on right side slope is positive, on the other side the slope is negative, left side slope is negative. Exactly at minima the slope becomes 0, isn't it? which means the slope changes its sign. That is important. Slope changes, this observation important. Slope changes its sign from positive to negative at minima. This is very important observation. The other interesting observation, imagine this is just see, imagine this is my plot, isn't it? If you have, what happens here? You have slope at let me check slope at s1. If you observe carefully, this is first point. Here I can find slope. I can find slope at s2, isn't it? As you are moving from like this, here slope you can find slope, here also you can find slope, here also you can find slope, but slope decreases. That's what it says. As you are moving from here to here, what happens? As you move closer to x star, your slope reduces. isn't it? You are coming from x0 to x star, isn't it? Coming from x0 to x star. If you are coming from this side, slope decreases, isn't it? If you are coming from this side, slope increases. Slope here slope is negative. That's what we are saying. Here slope is positive. Here slope is 0, isn't it? Slope, as you are going from one side to other side, you are going from positive value to negative value. For example, you are moving from this direction to this direction. Your slope value is changing from positive value to negative value. Using these simple observations in geometry, let's go and understand. Let's go and understand how does gradient descent algorithm works. In my next lecture, I will continue how does this gradient descent algorithm works. We will try to understand in my next lecture, that is in lecture number 521. Thank you very much.